Okay. Hi, everyone. Thanks for coming this morning. Might as well just get started on the agenda, which is to first thing take a look at what happened last week real quick, just to see if we're keeping up on our action items, which I'm not entirely sure we have. We had the tooling presentation last week. I think he sent out the slides to all of us. So if anyone didn't get them and wants them, then by all means ask and we can send them. It was interesting stuff. Hopefully we can talk about those things some more. And then we had a little bit of a conversation around process for the working group, which is how do we want to put process around adopting new projects and adding new members to the organization / the teams for different roles. Because our governance model is not like set in stone yet, and I don't think it needs to be until we're a little bit more established. So I have a PR open on the community repo to try and add just a little bit of process and clarity around what certain things are, a really minimal set of things. So we can go over that later when we're looking at community PRs. That'll probably be a regular agenda item because that's where, or pull requests and issues, which is where membership requests and project adoption requests and things will go, so that we just have one place to look for all these process-based things. So that's everything for last. We also wanted to, so that was one of the action items, was to draft a process. The process that's been drafted is very, very minimal, which is open an issue and then at the regular meeting we'll vote on it. The other thing was to triage some of the new issues on the board, which we have not done in the last 2 weeks. So what we may spend some time doing at the end of this meeting is doing board triage to see if we can add some labels like good first issue, enhancement, bug, that sort of stuff, to things that are aggregated on the board. That's all the upfront housekeeping that we need to take care of. Today we have Ben Goldschmidt from Selexica, who is going to tell us about some performance tooling. So if you're ready, Ben, otherwise we can stall.
I think I'm ready. So can you give me the screen?
Yeah, if you're able to take over the screen share, let me know if you have any problems with that.
Okay. Can you see my screen?
Not yet.
Oh, wait. How about now?
Yes.
Yep.
All right. Can you see a presentation?
Yep.
All right. Cool.
Yeah.
Excuse me? Okay, maybe I'll just start. And please interrupt me if I'm too fast, because I think the audience is pretty much worldwide at this point, and I don't know how good my internet connection is here. All right, so I'll today present the SLX performance testing platform. We also presented that at ROSCON this year and got a lot of good feedback. And via a connection from Dejan, we also had the connection to Thomas and to Amazon. And we basically got the invitation to present it here, so I'm very happy to do that. For the motivation, I'll try to keep that as brief as possible. So generally, something that we saw is that ROS 1 or 2 systems are typically so complex that you cannot test them completely statically, right? In both analysis and verification. The tooling that we saw on the market mostly covers functional verification. So you will find lots of things for unit tests. You will find very good platforms for verification. But there's not much for dynamic analysis of these stacks. You have lots of tracing tools and you can patch them together. But typically the problem that you have then is that this ends up in a script, and it's really not that much scalable, and you have to think through it again and again, because you basically only use it on demand. So there's no systematic way in it. And if you take, for example, ROS 2 with a large number of test cases or any other project, then you quickly have the problem that these benchtop setups, if you even have something like that, they don't really scale for the problem that you have. And what typically happens in this kind of situations then is that performance or real-time behavior really takes the backseat, right? So you care so much about the functional behavior that only in the very last moments of a project or a product release, you try to take a look at what's actually happening on the system, and then maybe you could discover some bugs and they move the release out, or even worse, you only find these bugs when the product is already in the field. And what we want to do is basically make this kind of testing, this dynamic performance testing, basically a first-class citizen, so that you can have it directly in your regular development flow. And this can be considered directly from the beginning, not when it goes wrong in the end. And for that, we came up with what we call SLX performance testing platform. And here I have to mention that the name is not yet final, so we are working on finding something that's a little bit shorter than this. And what we do there is we try to provide all the things that you need in order to run these tests. So the first thing that we want to do is we automatically want to find performance outliers for you, because that's essentially what will be causing problems when it's becoming unexpected. For that, we run different tracing tools on different tracing levels. So this includes, for example, system level. We also run ROS tracing, but also on module level. And then we run the scenario multiple times, and we take all that data that we gather and run some analysis on it. And the cool thing is that all of this you can also easily integrate into your CI. It's basically a set of command line tools and APIs, so it's very easy usable. So you can really integrate that into your development flow, and basically whenever someone commits something or you merge a PR, you will get performance information. And if you set certain constraints, which is also possible, you will directly see that something fails. Then you can send a mail to the developer, and it can be fixed before it becomes a problem, and you know it immediately. One thing that was, when we started doing this, becoming very obvious is we gathered so much data that visualizing the data became a big challenge, because I can run, for example, your test application 20 times and generate gunshots of context switches. And depending on the runtime of your application, you end up with millions of events. So it's literally impossible to go over all of them. So somehow connecting this data and making it easily accessible became a big challenge, where we spent a lot of time on it. And what we call this interactive root cause analysis. This is also something that I will live demo in a few minutes. And this is also what we demoed at ROSCON. One thing, basically coming from the motivation, we want to build this highly scalable. So we support multiple different workflows. So you can either have this running on a regular desktop PC, as I have at the moment, or you have a server that you have on premise, or you have a cloud setup, maybe even at AWS. And we also have an open API. So if you want to automate any of these steps or use the tool in ways which we have not even thought of, we try to make that as much possible as we can. All right, with that, I would move to the demo if there are not any questions currently. I take that as a no. All right. So here we see our front end. So we use for visualization Jupyter Notebook. So this is an instance of a Jupyter Lab server. And the reason we do that is very simple, because we will make the data available via an API call. And we like these notebooks so much because if you use this data, and this is the first example how you can use it to get the data, and you decide, oh, I want to scrub something. I want to use maybe a very simple loop on it and do something before I put it into the visualization. With this kind of tooling, it's possible. And the example which I'm going to show today is an application from the Autoware Auto open source driving stack. It's ROS2 based. Excuse me. And they have a LiDAR perception pipeline, which you can see here where I draw a very little diagram of it. So it consists of a Velodyne LiDAR driver, which basically gets UDP data continuously. It creates point clouds from it and then feeds those point clouds to a ground filter and to a downsampling node. And the downsampling node you can see here on the right which basically separates these wavefronts into points on the ground and points in the air, basically. And since that 3D perception stack will be running as part of a regular autonomous driving car and will be used for object detection, you want to make sure that it has a certain maximum latency in order to guarantee that you're not hitting something because the results took too long to get in. So what we will do is we have this scenario running in our CI pipeline. So every time a new commit happens, we are going to check it. And excuse me again, I'm having a little cold. So what we do is every time someone runs a commit, we check it again. We provide these performance results, which you will see in a second. And with these results, you can then directly take a look if everything is okay, or if you want to change something because you found a performance regression. And the first thing that we do is we initialize our API. So you see just a call here, and then we get the data. We provided some text to find it. So I can just step through here. And once I've done that, I have all the data loaded, and I can basically start visualizing it. And here, I think I'm going to make it a little bit bigger so you can see it on the screen a little bit better. So here we have on the x-axis a number of commits, so the last 5 commits in this case. And on the y-axis, we have the latency, which I showed you in the example that we measured. And for each of those commits, we automatically run the test scenario 20 times. And that generated a set of statistics, which you can see here. So if we use this tooling and zoom in, you can see, okay, this is actually a box plot. And if I mouse over, I also get the regular statistics that you would expect for a box plot. And here you can see already the first benefit of the tool, because if you just take a look at a certain statistical quantity, for example, here the median, you may come to the conclusion that the results are actually fine because the median tells you it's at 104 milliseconds. My constraint is at 120 milliseconds. So this is fine. But as you can already see from the chart, you have these big outliers here. And at that point, we thought, okay, this is somewhat helpful. I now know that each of those problems have a commit, it has a problem, but I don't specifically know why it has a problem. So we thought how we can make this more accessible. And what we did is we basically created a connection through all the data, which allows us to be able to move to the next level. So I can click on this result here in the middle where I have this biggest outlier, and it would automatically take me to the next chart. And now I see only the results for this specific commit. Yeah, you can see here on the x-axis I have the latency in milliseconds, and on the y-axis the count. So this is a regular latency histogram. You can also see that I have my constraint put in here at 120 milliseconds again. And you can see that most of the data seems to be fine. However, I have these large outliers. And this is helpful again, but how do you use this to debug something, right? So this is just an indication that things are wrong and that they are wrong more than one time. So we connected this even further. So I can now, for example, select the biggest outlier here, which is roughly 8 times over the allowed limit, and click on that again, and it will take me to the next level. And by the way, all of these levels are connected, so I can jump through them and click back and forth. So this is really cool. And now I see the result, the measurement that produced this big outlier. And you can see here on the x-axis, I have the time in seconds. So we ran the scenario roughly for 30 seconds. I have the latency again on the y-axis. And you can see how the latency in this scenario that we ran developed over time. And the first thing you see is that at the beginning, everything seems fine. We're pretty close to our deadline. However, we are below it. And only in the middle, we have this very, very big peak. And afterwards, there's some irregular behavior, but then everything seems fine again, though at a much lower plateau. And at this point, you see, okay, this has become really helpful, because now I know that maybe I don't have a systematic problem, but a spurious problem, which may be an indication for debugging. The The problem is if you have spurious problems, those are typically the hardest to debug because they're very hard to reproduce or to find. So we try to, even in those situations, make the data more accessible and provide you even more information. So that ideally, in the best case, you don't even have to spend a lot of time trying to reproduce this, but you have all the information already available in order to, limit the scope or limit the sources of this bug. So what you can do again is you can click on this. So here I'm going to click precisely at the point in time when we have this jump. Yes, excuse me?
I don't know.
Continue, I guess.
Yeah.
Okay. So when I click on this peak, so I can take you back quickly again. So I click on here. So then I move to the exact point in time when that peak happened, and I have the complete system state or part of the system state at that point in time. So you can see here on the x-axis, I have the timeline. So I've marked where I clicked here, and I have the CPUs that were in the system. So in this case, this was a measurement on a very small ARM platform. So there you can see we support both ARM and x86 for our tooling. And you can see here the processes and everything that was running at this point in time. And this is a regular CPU Gantt chart, which you can use. And I can zoom in even more. And here I can immediately see, okay, at the point in time this happens, CPU 3 wasn't busy. So at that point, I may come to the conclusion, all right, maybe it's not a load issue in itself, but maybe it's something else. I also can see which kind of processes were running at which point percentage. And then I also have the ability to move a bit back and forwards in time to maybe see an earlier point. And what you can't see here, because this is currently under development, we will also put the ROS events in here. So you can directly see when, for example, a node published a topic, or when a message was received, or a node was started, all of these events that happen in the ROS stack. And with this kind of information, and we try to add more and more to it, we hope that it becomes really easy to understand and debug this problem. And just to resolve this, I think in this case, the problem was that we did use a Linux without a real-time kernel, so we did not provide any priorities for the processes. So probably the kernel just scheduled whatever process was next according to the fair scheduler. And that way, the deadline was missed because it wasn't obvious for the scheduler that the one process really had to run at this point in time. And yeah, you probably can, or hopefully can imagine how this can become really helpful for a lot of problems. So I mentioned before that we run this in our CI pipeline. So this is just the front end, the result that developers get when they basically get the CI results. But I also mentioned that you basically, once the results has run through, can automatically check for the results. And you can see here, this is a very simple API call that we have here. By the way, it's not final, so we are still working on that. And with that, I can quickly check if any of the commits that I made violated my constraints. And you can see here, you get a little bit of debug output. And in the end, this is the most important one. You get the false flag here, which you can use in your pipeline to basically stop everything downstream in the pipeline. If you make this a critical error, then you can mark the build as failed and send emails around and do all the things that you would typically do in your CI. Now, this is just a very small example of the metrics we support. So these are latency measurements. So we can measure between typical ROS interactions that you have. Again, as explained, messages sent or received, for example. But you're also able to add custom trace points to your application to measure between any point in your application that you want to. Next to this, we also support a variety of other metrics. So you can also measure CPU load and constrain it. You can have network traffic that we will provide, and some more statistics based on ROS topics and nodes and the messages that they send or receive. And yeah, maybe also because it was asked a lot at ROSCON, so we're planning to have the first release out at the end of January. And then go from there, basically. So that concludes my my demos. And now, yeah, if you have any questions, let me know.
Awesome.
Yeah, I mean, the visualization and the reflection is really extremely helpful. Just looking at it, I can see there's a lot of quality coming. What exactly is the build doing special to select all those data you need?
Excuse me, I didn't get the last part.
Oh, what is the? I mean, what do you need in the build to actually produce all these data for the front end?
Yeah, it's a good question. So we need certain packages installed that we need for our tracing, which we use. You need some little bit of tooling from us. So we have a wrapper where you basically just give us your application call, can be literally anything you would normally execute. And once you do that, and we have also some things with Yocto where we automatically integrate that. So if you want to really build an embedded image, then we generate the trace results, and we will store them on the platform, and then you can copy them from there and basically import them with our tools into our big results database, or do that directly on the platform depending on what you do.
Okay, you mentioned at the beginning you talked with Apex about performance stuff. Does it use anything of the performance testing stuff Apex has done in the past, or is it independent? You can basically run it on any kind of application.
We can run this on any application. So I always make the example for if you have an interest and want to know what, for example, Tux Racer is doing or Minesweeper, you can just run it with that as well. It will not obviously get you some information on ROS because those applications are not ROS based, but you can run it with any application that you want, or any set of applications to be precise.
I had a quick question, which is, are we muted? What if we're not muted? No. What if any parts of the tooling here are currently open sourced, and are there any plans to open source anything else?
So, I mean, we've gotten this question before, and we discussed it. So currently we don't have any plans to open source this. However, what we want to do is, and this is something which we are working together with the real-time working group, where we have a meeting next week, is we want to use this tooling. And again, this is just in proposal stage, so we will discuss this for the first time next week. We want to provide reports from this tooling for ROS2 and some specific real-time applications automatically, so that we have to discuss the cadence maybe at first weekly, and then we will ramp this up, so that at certain points in time, for the current master of ROS2 development, you get these reports. So you can take this directly into account in the development, and basically we want to use this as a starting point, and then figure out how we make this more available, for example, to the community, because we also have to go to give back to the ROS community.
Yeah, it seems like maybe the at least the dashboard generator Python API here perhaps is, and that's something for sure.
Yeah.
Anybody else have any other questions?
Maybe I can just ask again. So I discussed with Ben in the past around this subject, and so I think there is a bit of work, to make sure that like the analysis tool is tracking the ROS2 development, because basically what you're doing here is that you're symbol based to intercept and measure some part of your system, and given how fast symbols are getting renamed, added or removed in ROS2, that can be a bit of a burden. Ben, do you have again a bit like what Emerson was saying? So what is your plan, in terms of engagement with the ROS2 community, and how does the working group, could help you with that? Yeah. Like, do you imagine having an open source project that would be the Silexica project for ROS2 that everyone would contribute, or is it something
like the integration layer or something that would let people get access to this performance data from their application or something like that?
Or is it something you host end to end and you're just gonna provide a website, that would be publicly accessible? Trying to figure out what is your plan for next year.
Yeah, so currently we don't have a concrete plan for that, but you're raising a very good point, because we already saw that, because when we wrote our tracing module for ROS2, someone accidentally took some API calls from ROS2 Crystal, and then our tooling didn't work anymore for ROS2 dashing because there were some internal changes that happened there. Yeah. So something that I can very well imagine is that we open up, especially this integration layer, and create something of a plugin system, because I think it's really easy to intercept these ROS calls. Well, not really easy, but once you see how we do this, it's straightforward. And this could be something that is maybe maintained in parallel to the current ROS master development. So if something changes in the APIs or symbols that we use, that this is directly adapted. And I think having something like this open source is probably the fastest way and the most efficient way to do this. But again, I'll take this back and we'll discuss this, but I like the idea.
Yeah, cool. I mean, we're definitely trying to put a lot of checks on the repositories under this working group. So performance data is potentially one of those checks we could be adding to the regular stuff in the future. So unless anyone has any other pressing questions, I don't want to cut this short, but we also have other things to attend to. So unless there's any objections, I'd like to move on to the next thing. Thanks so much, Ben. Oh, yeah.
One more question. The only thing where I could see it limited by being run on like an already existing commit or something is if somebody, like, you find an issue where it's really bad, right? You debug it, you make code changes, you kind of want to be able to run that locally in order to like verify that you actually did better, right? So the round trip type of waiting for the CI to kick in, even if it's weekly or daily, or even on a pull request, might already be really slow, right? Just as a thought. I mean, I know it's hard to consider how to share it with other people that they can run it, but just as a thought.
But here's the important thing. So you can run this completely on your own PC, right? So we currently generate regular Debian packages. So we'll just provide an updates server for your apt, basically, and then you install it, and you can run it all on your PC to run it whenever you want, however fast you want, so that you have a really fast and efficient workflow. So you not necessarily need a big database or a big server or a cloud connection or any of that. So that's certainly something that's possible.
Okay. Thanks for clarifying. That's good.
Okay, cool. Thanks so much. Really appreciate the presentation.
Oh, you're welcome.
And then I will take back over the screen share. Oh, let's see, how's that work here? Share. Oh, the little local thing seems to have preference over other screen shares. So I like how this is going. It's okay, as long as I don't look at the Chime page, it's fine. So the next thing we want to look at is project status updates. I think I can give so right now the projects that are under this working group are Crosscompile tool, system metrics collector node, which is fairly new but is making progress. I don't think it's hit its first release yet. ROSBag 2 now is under the umbrella, and then we're also working on the GitHub Actions-based CI infrastructure for the packages on this repo. Those are currently what we were working on and focusing on. So for the cross-compile tool, I can say that there has been no changes made in the last 2 weeks, I believe.
Something we may want to indicate, though, is that we're currently planning to implement ROS1 support in Crosscompile, and we're actively working on the design and trying to write some POC.
Yeah.
So soon we will have the ability to also do cross-compilation for kinetic and melodic.
those two specifically. Also, we're working on an enhancement to the tool to target arbitrary tool chains provided by the user. Right now, it really only just uses the tool chain you can install from apt for ARM64 targets. So it's limited right now, though it supports the Raspberry Pi use case. But what we want to do is start supporting more arbitrary boards. So there's planning and proof of concept work going on for those extended workflows. So that's what's going on there. Nothing's gone into it in last iteration. System metrics collector. Do we have anyone here who's got more context than me on that?
Well, I can give, again, like it's pretty much in flight, but what is keeping people busy is one, working on actually implementing the publishing logic, because the first round of PR was more around like collecting data independently of how you put that on on ROS. And second is, I think Devin is looking into making that as a composable node, so that basically you can inject the component in any executor and observe process-wide metrics easily. So that's also something that is gonna land soon.
Yeah. Okay, cool. So that sounds like we're really close to what we called the bar for the first release on it, right? Is like it gets CPU and memory for system and specific process, and then publishes it on a message and topic that we have defined as the metric standard, at least for a proposal for it. Yeah.
Yeah.
Okay.
That's the plan.
So then we'll bloom that once we get the functionality in place.
Yes.
Cool. Perhaps Zach, you have some context on the work we've been doing on ROS bag.
And we have Karsten also.
Yeah, and we have Preston also.
Yeah, the work our team has been working on has been to add compression to ROSBag 2. Anas is working on supporting Z standard in ROSBag 2. It's work in progress right now.
Cool. Karsten, any updates we should note?
No, I'm good from my side. I haven't had much updates.
And maybe from my side, this is Ben from the Lexica. Carsten, we talked at ROSCON. I have not forgotten that we want to file a bug report for you with the data that we have. Unfortunately, as you may understand, we are very busy, but it's on my list. It will come.
That's okay. I appreciate it, though.
Cool. Then Thomas, you've got the context on this.
Yeah.
Actions.
So let me just think about it. Yeah, so what landed already is that we now have C++ coverage for, we have coverage for C++ packages, which was broken until yesterday. So we have system metrics collector reporting to CodeCove now automatically based on the GitHub action. So we have Windows support. It's a big one. It's not 100% there. I'm still like finding bugs, but the gist of the work has landed. And I am right now adding support for, it should be done by end of day today, supporting ROS1 and ROS2 binary installations on Linux, so that you don't need to build everything from source, and you can also test against releases such as dashing or melodic or whatever you want.
Cool.
Yeah, and next is ROS1 bridge.
Yeah. Oh yeah. GitHub Actions. There's the open PR to add it to ROSBag 2.
Oh yeah, and we have two open PRs. Yeah, one to add the linters to ROSBag 2 independently without compiling the code to get quick feedback, and another one. You're right. We have also the full thing, like the build and test from source end to end.
Great. So it's good to see them being starting to be used on all the projects. And OS X support, is that still just like on the roadmap?
OS X support, it's done for Python packages. I didn't enable it on System Metrics Collector because somehow it's failing to find RMW plugins on OS X, and I could not understand if it's a problem on my side. Well, it's most likely a problem on my side, and how to fix it.
Okay, so ongoing. Yeah.
Yeah, I mean, again, we're mostly there. It's a bit like Windows. We need to iron out those last bugs.
Yeah, and I'm not sure if there's any external interest in working on this yet, but we should start to. You and I should at least sit down and try to groom the backlog a little bit to put like good first issue things if we can.
Yes. Yes.
Because it'd be nice to make that at least accessible, even if there's no one immediately going to work on it.
Yeah, no, I agree, and I'm still behind on like posting on Discord to announce that stuff. But
well, I mean, we still are feeling it out. I get that.
Yeah.
Cool. Okay, so that's all the project statuses right now. So one new thing I added to the regular agenda is community issues review, which is we have this community repo, which we're going to try and use for process for the working group, have one place to collect everything. And let's see, so we'll look at issues, which is cross-compile CI improvements, which is maybe something we should actually move over to the cross-compile repo instead of having here in community, right? Or have a project repo for the CI tools.
I mean, yeah.
Like either cross-compile or the CI tools, because I think community we're just gonna reserve for process stuff, but we can take care of this later.
Yeah, I mean, it's because I was not sure if you want to have epics in repos or here, like the same way we do it for the team.
Yeah, I think in repos is fine because we're going to try and treat the sub projects as mostly independent. Yeah. Okay. So then pull requests. I added last night a first draft of a README and some issue templates for. To sort of kick off a little bit of the process here, just formalize things so it's easy. I don't know if everyone wants to just go take a look at that real quick, but I tried to be short, as short as possible. I can just go over it. What if we do, how do I do not side by side?
Yeah, here. Yes.
Okay, so basic idea is set this little mission statement for the tooling working group, which is provide ROS2 users with simple, robust, easy tools for recording, debugging, visualization, and introspection. That covers a lot of things. Maybe it's not even broad enough, but maybe it's plenty. I don't know. It's hard to say. And there's a section later on that's scope, which we just said like things that are in scope right now are sub-projects we own here, and things that are out of scope are things that we don't own, and specifically middleware and communication stuff is out of scope for this working group. But I've kept it really quite limited here. The next thing is we list out the sub-projects that are owned here, and this was just a direct list of the repositories in this organization. So this will grow as we accept new projects, or we need to define a deprecation path as well. Action items, define deprecation path, because there is the distinct possibility that projects will wither and die eventually if there's just no interest in them or nobody left to maintain them. We'll have to figure out how that works. Yes, so I've added an issue template for two things, which is one is adding a new subproject to the organization. So this is the opening the issue according to the template is the way to start the conversation about getting a project under the working group umbrella. I think for now what we'll do is we'll just review those at every meeting, at the regularly scheduled meeting, and vote on whether we want to bring it into the organization. And I don't know, what do we want? Super majority? We can argue about it the first time it happens, I think.
I mean, so what Kubernetes is doing is lazy consensus.
Lazy consensus, which is what?
It's basically you define, like what it means if someone does not say yes or no, and then you just
and then you go for a majority.
Yeah.
I see. Okay. Well, we can do that for now. So whoever's at the meeting when we discuss it, if there's a majority of those people, then they can also send in their concerns if it's a bad time for them, like the middle of the night. Okay.
I mean, maybe for voting decision, I think just to track it and make sure it's transparent, I would like it to, people to just answer an issue every time. Independently of whether we do the final call in the meetings, that can be the time.
For sure.
Just make sure we just don't do that early, just so that we keep a track.
Makes sense. Okay. And then I've tried to define here really a list of standards for subprojects, because I felt like if we're having things and we're a working group and we worked on things, we dedicate time to this, we need to have some sort of promise that we're making if we have a project here. I think that it's not worth just having this be a dump of things that people think are cool, because personal GitHub accounts or separate organizations are perfectly acceptable for that. I think if we're going to work on a project here, we need to meet some set of standards that we agree on. And I've taken a first draft at a list here, which is that the build passes against the current master of ROS 2, that the standard linter set is enabled and fully passes, that there are no warnings on the build, that the quality builds are green for this package, which is the ones that we worked on at the very beginning of 2019, which is the ASAN, TSAN, and the Clang thread safety analysis ones. That all the tests pass, and so that above, like this set of things, is really just builds are green, and we'll be making a dashboard as well here, probably in this README, to list the status of all of the projects that are here, and then a couple more things is like reasonable code coverage, issues are responded to promptly, and releases go out regularly. These things are not well defined, and I didn't feel like it was a good use of time to strictly define them right now. But as long as there's sort of a statement of intention there, I think that's good. And then last thing is a definition of roles, which is kept also small for now, in that we have members. Anyone can be a member, and members get issue triage privileges, so they can move around issues, add labels, stuff like that. And then sort of it goes up in scope to reviewers who are, I'm not sure actually what the difference is on privileges on GitHub right now.
So I was about to get to that. Maybe we need to make a table and have a mapping to exactly what it means. GitHub permissions. Yeah. So it's triaging. The interest of having a group is that I think for me reviewers kind of promise to do some kind of rest for an SLO, so you can assign them to reviews, basically.
Oh yeah, we were talking about they'd be auto-assigned on a rotation to PRs.
Yeah.
At least, so maybe we need to, for now I think it's safe because this is really limited and we can add a more strict definition of what these mean. I'd like to maybe just get this in there so that people can see what our basic layout of this working group is.
And also, no, I agree. And also, what it gives you is that if your reviewers is already okay with the code, then the approver just do a sanity check and merge stuff. Yeah,
exactly. So that was, the next one is that approver is one step above reviewer, where they actually have merge access to the repo they're an approver on. And then the subproject owner is the admin for the repos of that particular subproject. Thinking about subprojects as not necessarily being one repo, which is why there's a separate term from repository, because I think this like GitHub action CI things is, I'm considering it one subproject on the organization, and so the subproject owner would be admin on all those repos.
And it's the same thing for us back too, right? I mean,
there's more than one repository. Yeah, exactly. Cool. So to go up, I've made these issue templates, one for request project edition, which is a description of like, what is this and why do you want it here? The existing URL of it, the subproject owner, because we need to have an owner for everything just so we can have an admin on it. A little checklist that the requirements are met for the standards we laid out, and then sponsors. I don't know. That came from the Kubernetes template. I'm not sure if we need that as part of the process, so I just said if applicable, but left it there.
Yeah.
All
right.
And then membership request, which is username, organization, which is this one, requirements, sponsors again if applicable, and then just a list of contributions to if you want to. So this one is like really easy. If you want to be a member, just go ahead and open it, and you don't need any real justification. Interest is the bar right now. Yeah.
All right.
Does anyone have any concerns about anything on here? If not, I'd like to merge this in so people can start creating issues and have a top level idea of how to begin participating. Nothing? No questions, comments? Okay.
The one question I have is you were talking about you voting to take in a project, but you didn't really specify who is a valid vote. Is that just all members?
Right now, I'd say all members. Yeah.
I mean, if you have no bar to become a member, is that not?
I feel like we need to be concerned about that only when it becomes a problem. I don't know.
And and also because there is a member. Maybe the bar to be a member is to have regular contributions, whatever it means. And if someone didn't show up for 6 months, then we just drop privileges, and he can, they would be able to reapply if they want to.
So I'd like to more strictly define these things, but I don't want to add too much process too early to encumber our initial phases. Does that make sense?
Yeah, totally. I just wanted to raise what might be a concern eventually, but I agree it's not really problematic right now.
Cool. Yeah. On board. Same page.
Yeah, and I definitely there's definitely problems here with vote packing that you could there's a lot of things you could do to game this system right now, and we all understand that.
Yeah.
Let's not do that.
We're making an assumption of a good faith participation.
Yeah. And as soon as we see that's not the case, let's define better rules.
Yeah, I think that's the bar one set.
Yeah.
So, thank you for your approval, Thomas. I will merge this. Great. So now, if we look at this, we have a README now, which is nice. Community will be the place to go for community things. And then, if we go to issues, new issue. Oh. I'll have to figure out why the issue templates aren't showing up, but we don't have to figure that out on here. Anyways. Cool. That's that for that discussion that I wanted to have. Before we get into a project board, which is nitty-gritty looking at things, is there any discussions anyone else wanted to have here? Any regular agenda items I should have just open mic. Does anybody have anything specific on their mind that they think should be part of this working group, should not be? Any discussions that someone wanted to bring up. I just want to make sure to make time for that. Okay, sounds like there's nothing. In which case, we can go over to the project board. And it looks like, should we work backwards or forwards? What do you think? I'll start backwards. To say, we've got a few PRs open on ROSBag 2. Oh, except these are all drafts, aren't they? All these gray ones?
Yeah, that would be I think that's what it means.
Okay, so all of these drafts are, we should not pay attention to looking at them until they are just checking. This is open. Why are they gray? Have I gone colorblind?
Maybe then.
Okay, so we'll just have to make sure to take a look at these. A few of these ROSBag 2 ones. I know we're doing reviews between some of us here. I'm sure you're aware of what's going on there, Karsten. But for anyone else who's interested, it looks like compression work is coming along, and I want to take a look. Okay, so right now we are working on GitHub Actions, support for, thread safety analysis. That's great. Yeah, those builds have been, having done those builds actually really helped with cross-compiling stuff because we added things forcing cross-compiler tool chains into them, or not cross-compile, but forcing tool chains. Then backlog, we've got cross-compile work, which I don't know if we're immediately planning to do this until we have,
Sorry.
That's okay. Cross-compile, we've backlogged some of these issues. I guess these are things that anybody could pick up. I don't know if we'd necessarily plan to do them immediately.
Yeah, so there are a few things that we're going to need to do.
Yeah, we should.
The steps. I think the biggest one are like the. Yeah, so this one is documentation issue, but this one is important because we want to put this tool in a state where it's actually usable easily.
Yeah. Do we want to have a separate label for like verified or important or something like that, just to show that we've triaged it?
But we have that as a pipeline. It seems that it's redundant. I agree it's not ideal because I don't think you can see that information without
the
ZenHub.
But so you can open the ZenHub web app, and I think that's where we should point people instead of at the GitHub-based link in case they don't have the extension.
Yeah, I tend to agree with that.
So let's see, do I have this new label? All right, documentation, there we go. Yeah, so that's what I'm gonna do here on out. If anyone has any interest in helping to groom backlogs, like, you know, a little bit of project management work, not necessarily implementation work. If there's any interest whatsoever, please let me know. Super happy to collaborate on that. Don't necessarily want to have to do 100% of it myself. So if that's something that anyone on the phone is interested in, you can ping me offline and we can work on that sort of thing. We're 5 minutes to the hour. I think it's a reasonable place to call it because we don't have this well groomed. What we want to do is, this was the action item for last time. I think it will remain the action item for this time is groom and label issues to get work assignments easier.
Something we could do also is to start creating milestones so that we have like sprints, you know, because this way we can actually track velocity and make sure that we are making progress.
Yeah, the milestones can be vague. We should also just make like an F release.
Label.
There's releases in the ZenHub thing.
Oh wow. Okay.
So milestones are like sprints, and releases are not time boxed necessarily. They're like scope boxed.
That's a great idea.
Yeah. So I think we should make an F release and start putting like big features in there that we would really like to hit for these projects, so that we can try and get way out in front of that.
Yeah.
Cool.
All right.
Yeah, unless anyone's got anything else they would like to bring up, that is a working group meeting. Cool.
Thanks for coming, everybody.
Yeah, thanks very much.
Have a good weekend.
Bye, everybody.
Thanks, everybody.
Thank you.